Okay, thank you. So this is going to be 40 to 45 minutes of discussion exclusively on the analytical questions, which you need to be prepared. All right. So hope my screen is visible to all of you.
Yes, sir.
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Great, great, great. Don't hesitate to practice along with me. And if you are not understanding, don't hesitate to ask questions also. So first question, what is the area contained within -1 and +2 standard deviation of a normal curve? You all know about normal curve, right?
Yes, sir.
The center is average and ±1 standard deviation. You will have 68.27% of the area, isn't it?
Yes.
Plus
Yes.
or minus 1 standard deviation. So
Yes.
now they are not exactly asking for +or -1 standard deviation.
Yes.
-1 on the left side, but +2 on the right side.
The side. Yes.
When I say -2 and +2, then the area will be 95.45.
5%. Yes.
So definitely the answer is between the two. So how are you going to calculate? Anybody do you have
Sir,
any idea?
81%, sir. 81.0.8185.
Very good. Fantastic. You have done some homework. That means, right? Otherwise, you can't easily work it out. So now here are the workings. You see the normal distribution curve, all of you can see.
Yes, sir.
And now the point is, we need to know the area from -1 and up to +2. +2 is this line.
Yes.
-1 to +1, this is already known. 68.27. I have written here, you can see.
Yes, sir.
But what is this shaded area from +1 to +2? In order to find out, you should know what will be the area from -2 to +2.
Yes.
-2 to +2 is 95.4.
95%.
95.4.
And this white color area, I don't want, 68.27. So the remaining is 27.18. Half of the 27.18 is the shaded area. Am I right?
Yes.
So half of this is 13.59. So the white color area, which is 68.27, then the shaded area 13.59. So what is the total area? 81.86.
81.86.
So the best option here is 0.8185. How many of you understand my explanation?
Understood, sir.
Understood.
Understood, sir.
This
Very,
you have already,
very, yeah,
so this you have already explained in class also, sir.
very good. That's great. See, this is how nature will behave. If you are earning 1 lakh rupees, 68% of the money you will be spending here. That's the idea, right? So, particularly with respect to the data, this will work out very well. So that is what we call it as normal distribution. So please remember this. But even if you don't remember any of these values, 68, 95, and 99.73, and so on, you can use Minitab and find out the answer. Minitab method also I'll show you. But this particular problem, I don't think Minitab or Excel is required. Even simple hand method, you can solve this. So that was not a tough job. Now moving on to the next question. A random variable X, you see here, a random variable capital X is normally distributed. When you can read this symbol in this manner.
Okay.
A random variable X is normally distributed with a central tendency or average of 80, standard deviation of 2. So what are the two numbers inside the bracket? One is average, other one is standard deviation. And now X is the mark scored by the green belt student in the mock test. What is the probability that the student's score will be between 75 and 85? You have some information about the student's marks. What is that information? Marks are randomly distributed with
Yes.
average of 80, standard deviation of 2. Now, what is the chance for a student to score between 75 and 85? If you could find out the probability, you can take decision, isn't it? So now,
Yes.
how can we calculate this? We know in terms of standard deviation. In terms of standard deviation, we know 68.27,
Yes.
90.45, 99.73. But here, in terms of standard deviation means it's a hypothetical scenario, statistical scenario. isn't it? But here what you see in my slide is a real-time scenario. So
Yes.
can you convert the real-time scenario into a statistical scenario? So you have to convert the real-time scenario into a statistical scenario. For that only, we convert the random variable X into a statistical variable G score, isn't it? So G score is always expressed in terms of number of standard deviation. So that you can understand. -1 to +1, it is 68.27. -2 to +2 is 95.45. -3 to +3 is 99.73. So you need to convert these marks into G score, and then you can actually solve the problem. So I don't want to complicate the subject right now. Rather, I would like to explain this with the help of a Minitab, because Minitab will take the pain of converting, all the conversion formulas and give you the probability, right? So I stop sharing and I am going to open Minitab parallelly. So give me a minute. Minitab. Minitab. Oh. Yes. So it is just opening. By the way, anybody know the formula for G-score? As parallelly Minitab is opening. Any of you, do you know what is the formula for G-score? Formula for G-score is X bar minus mu divided by the error. X bar minus mu divided by the error. So Minitab got opened. So I'll share that Minitab screen. So you can see my Minitab screen now. Yes, so what I do is, oh God, lot of files open. Okay. So you can see my Minitab screen. So now I want you to go to graph. Now go to probability distribution plot. Now this will come. Now you click view probability, then OK. Now you see here, we want to work with normal distribution. So I choose normal distribution. What is the average of the students' mark? They have given
80.
80. And standard deviation is 2.
2.
This is a real-time scenario. Now shaded area. I want to calculate the probability between 2 points. So I choose the X value. 2 points means I can choose this point, this curve. Can you see the last curve?
Yes,
Yeah.
sir.
The probability from between X1 to X2. So what is my X1? 75.
75. 75, sir.
And X2 should be 85.
85, yes.
Now when I do this much, Minitab will tell me the chance for a student to score between 75 to 85. When the average mark is 80, what do you think is the chance for a student to score between 75 and 85, right? You can do the calculation manually or you just click OK. Minitab will tell you what is the area. Now, can you read from Minitab? What is the probability?
98.76.
98.99.
0.9876.
Yeah, you can, in terms of decimals, you can say 0.9876. In terms of percentage, you can say 98.76%. Since the class average is very healthy and variation is also very, very minimal, so literally every student has a chance. Literally every student has a chance to score between 75 and 85. This is the meaning. Because the standards are very high in the classroom. Can you understand, all of you? How do I say the teacher maintains a high standard? Because the teacher is able to maintain an average of how much? 80. Teacher is able to maintain a very, very low standard deviation of just 2 marks. So that's the reason why the chances are very high. Hope all of you understand this particular thing. Am I right?
Yes, sir.
Yes, sir.
Now, anybody, will you be able to do the same thing by yourself, by sharing your screen? We can allow you to share the screen, not a problem. Anybody ready?
Yes, sir.
Yeah, please do it. I will stop sharing. Now you can do it. You please stop share your screen and keep the Minitab open. And then all others can witness.
So is there a way we can also do this in Excel, sir? Because for some
Yes.
reason the Minitab is not working in my computer.
Now Excel, RK sir is the expert in Excel. So he can guide you. And he has developed a lot of templates. And I think he shared also one of such one. Finding the probability. Okay. So you can take RK sir's help, madam, if you want to do anything in Excel. Okay. So Marudu Pandey, you are sharing, right?
Yes, sir.
Yeah, you can go to graph.
Sir, they can't get minimize.
No problem. It is looking good. Now it is ready to work. You go to graph.
You can put me in a breakout room.
No, the
Why, sir?
options are can't
No
able
need,
to
no
see.
need. Okay, continue.
No, Marudu, your
Sir.
screen is visible very well.
Sir, screen is visible, but it in Zoom options are there.
Sir,
Available in outside.
Sir, I
Try
already
doing-
finished, sir. Sir, I'm already finished. I share the.
I don't understand. What do you
Sir.
want to do?
Sir, in Zoom options are the top side is available. I can't able to
Graph.
take the option. Graph option.
You want
Oh,
to
Minitab
go
is
to
not
graph.
working.
Okay.
Yeah,
You
probability
straight away go to
distribution.
graph. Yeah,
Prob-
graph,
probability
distribution.
distribution.
Then
Last
come to
one.
view.
Last
view
one,
prop.
yes, okay. Okay, then normal distribution.
You change the mean.
80,
Yeah.
80, 2, okay.
Shaded area.
Shaded area.
You got it. You got it,
Yeah.
right?
Yes,
Now
sir.
I want you to find out what is the chance for a student to score above 82 marks. Find out. You just cancel and then do it again. No need to save. That's it. Yeah. Go to graph. You go to graph. That's why, you have to be, used to. Otherwise, all these problems will come. Okay, go to graph. Fine. Do the same thing. Yeah.
The mean.
Same conditions. Only thing is, I want you to find out the chance for a student or a probability for a student to score above 82 marks. Choose the appropriate curve, right tile or left tile or both tile or middle.
Middle.
Why middle? I told you probability above 82 marks.
It'll be right tail.
Right tile.
Right tail. Right tail.
Right.
Choose the right tile. And now what is the mark?
82.
That's
80.
Now what is the chance for a student to score above 82 marks?
0.1.
0.15.
15.87%.
15.87%.
If you know how to calculate probability, you can decide well. What percentage of my products will have diameter more than 82 mm? Similar situation, isn't it? Instead of saying 82 marks, I'm saying, diameter above 82 mm. What is the chance for the surface finish to be above 82 microns? All that required is the average surface finish, average diameter, and standard deviation of the surface finish, standard deviation of the diameter. All of you, do you get me what I'm speaking?
Yes, sir.
Yes, sir.
You can use it. Suppose you know
Yes, sir.
the average sales is 80 lakhs. Average sales every month is 80 lakhs with the standard deviation of 2 lakhs. Now what is the chance for your sales team to achieve or to achieve a sales of above 90 lakhs? Do you think you will be able to calculate?
Yes, sir.
Yes, sir.
Similar thing, right? So if once you are able to calculate the probability, and if the probability is impressive, and for sure that is going to happen. If the probability is very, very low, then the chances are also low, right? And you can decide accordingly. Now the same situation, now you can go to shaded area. Suppose if this is diameter, this is length of a product. The average length is 80 mm. and the standard deviation of the length is 2 mm. Now I want to find out what is the chance for me to produce products below 75 mm. Below 75 mm, because it might get rejected. So in the X value, what should you type?
75 and it will be
Right.
left
Please
tail.
type
It should be
75.
left
It will be left tail.
Left tail it will
Left
be.
tail.
Left tail.
Left tile. Yeah,
Left
type
tail.
75.
Left tail, right.
75.
Now,
75.
yeah, give okay. That means if I produce 1,000 pieces, what do you think? How many pieces will have a dimension lesser than 75 mm?
0.06.
0.006.
0.6%.
6%.
0.6.
0.6%.
0.6.
See, already it is,
Very
it is
less.
0.0062 means
0.0.
0.62.
0.062.
0.62%, isn't it?
Yes,
In
sir.
terms of percentage, you multiply by 100. So it
Hmm.
is 0.62%. But my question is, if I produce 1,000 pieces, how many pieces will have length lesser than 75? 6.2 pieces,
6.2.
isn't it? Out of 1,000, just 6.2 pieces will have dimension lesser than 75. Is it clear to all of you?
Yes, sir.
Sir, sir, I have an office laptop, so I cannot install Minitab, but I have the web version with me, and I'm not able to plot it. Can I share my screen and just show you, and if you can guide me?
Yeah, you share your screen. It doesn't require any data straight away. You can work. Yeah, you can stop sharing, Mardu.
Okay, sir.
So, sir, this is
Yeah, go to graph, probability distribution plot. Then
yes,
choose view probability.
Yeah.
Give OK. And now you declare the mean and standard deviation you are given. Now go to options. Now which one you want, right tail or left tail?
Middle. Last one.
Okay. Then it will be 75 and 85 or whatever value according to the requirement, 75, 85. Now you give OK. And in your case, the graph will also appear inside the session window. That's all. Now you zoom out properly and then see.
yes, sir. Got it. Okay, thank you,
That's
sir.
all right.
And the numbers that come. Okay, I need to hover over them. Okay, I'll figure this out. Okay, thank you, sir.
Perfect. So we'll proceed now. Now we are a little bit familiar with how to use, how to handle the problems related to probability.
Yes, sir. It is very much clear now.
Now it need not be student's mark. It can be your product dimension. It can be your team performance, or it can be your marketing department's performance or sales team's performance. Will you be able to handle all kind of data? Because everything is finally a data. Please understand. Everything is finally a data. Only requirement to use this method is the data must be continuous data. That's all. It's a measurable characteristics. Now, what is the question here? Find the quartile 3 in a distribution which is normally distributed, in a variable which is normally distributed with average of 80 and standard deviation of 2. Do you know the meaning of quartile 3? One of you?
Yes, sir.
What is the meaning of quartile 3?
In the
Third quarter, sir. It contains 3 quarters.
Okay, but can you give me an operational definition so that all of us should be able to understand?
Sir,
The
it
same
includes
thing.
75%.
75% means?
Okay.
Oh, do you mean 75% in
25, 25, 25. It means like that, sir.
Will be
25 per
from
quarter.
20 from 50 to 75.
when we
side area,
graph chart it on
75%.
the
25 by 75.
See,
axis,
first
it
of
should be
all,
the-
quartile is a point. Quartile 3 is a point that will divide your distribution into 2 parts. Since it is quartile 3, the left side part will be 75%. 75% of the distribution will appear to the left of quartile 3. So what percentage will appear to the right of quartile 3?
25%.
25.
25.
So,
So 25 by 70.
75 on the left, 25 on the right. That point is known as quartile 3. So 50-50 means quartile 2. 25 on the left. 75 on the right means
One.
quartile 1. All right. So with that understanding, let me take you to Minitab again. Now going to graph, going to probability distribution plot, view probability. Okay. And the situation is mean 80, standard deviation 2, right? So I have taken. Now shaded area. Now what is that we want to find out? Quartile 3. Now
Left
you
tail is
take,
out of control.
you take right
Right
tile
tile.
or left tile, anything, right tile. When I take right tile, then what will be the area to the right of my quartile 3?
25, sir.
25.
25.
It
So
should be
I am
25.
choosing probability. I know probability, but I don't know the x value, right? So you choose the probability and type 0.25 here. What is my intention now? I want to find the value of this line. Value of the line is Q3. Now I give OK. Minitab will draw the distribution for me. Now, in this particular distribution, what is the value of quartile 3?
81.35.
81.35.
If I ask the students in the classroom, right? If I ask those students who scored above 81.35, what do you think? What percent of the students will stand up?
75% of the students will stand up.
Yeah. Above means 25 only. Below means 75%. Right? If I go to any class where the average mark is 80, standard deviation is 2. If I ask, the students to stand, if they have scored above 81.35, 25% of the class is
Will
expected to stand.
Right.
That is the idea, right?
Yes.
And now you want to find out Q2. See, Q2 is nothing but, the center. Q2 is nothing but the center.
That
Let
is
me show you
50-50, sir.
Yeah, 50-50. So let me go to the Q2. Same thing, view probability, okay. Now, everything I want to retain the same. This also I can retain. I'll say 0.5 here. Now, what do you think will be the answer? 50.
80.
80.
Yeah,
80.
sorry, yeah, 80. Because 50% on the right, 50% on the left. That is the center value. So this is my Q2.
Exact mean.
Exact midpoint,
Mean.
yes. And now I can find out the Q1 also, right? So view probability, okay. And shaded area. So now I want Q1. So I want to,
0.25.
75.
yeah,
0.75.
yeah, I will have the right tail only, no problem. But for Q1, I will now type 0.75 because I know for Q1, the right side area will be 0.75. So now you are able to see the Q1 value. All of you are with me?
Yes, sir.
Yes,
78.5.
So
sir.
whether it is Q1, whether it is Q2, whether it is Q3, or if they ask in the opposite way, what is the probability for a student to score above 78.65? 75%. What is the probability for a student to score above 80? 50%. Right? Suppose if I use Q3, maybe here or somewhere, right? 81.35, I think. Yeah, we have 81.35. What is the probability to score above 81.35? 25%.
25.
That's all right. This is how you can play. You can play with the Minitab and let them ask n number of questions. We'll use the same procedure and solve all situations. Isn't it? So this is done. Now, central limit theorem, I hope you all have studied. This is a theoretical question, but it requires thorough understanding on the central limit theorem. According to central limit theorem, regardless of the population from which data is drawn, the sampling distribution of the mean will be normally distributed. Is this statement always correct or always incorrect? Or is it conditionally correct or nothing is applicable? What is your choice now?
Conditionally correct. Because 30 sample minimum.
Yeah, conditionally correct, but we don't know whether it is 30 or not, right?
Yes, yes.
It should be sufficient.
Shit.
It depends on your population characteristics. If the population is normal, then even with a lesser sample size, you will be able to generate a normal distribution for the mean of your sample. See, all of you, you have to have a clarity on population, sample, and sampling. Population distribution, sample distribution, and the third one is sampling distribution. For example, so far we have trained about 5,000 people on Six Sigma. All right. Imagine black belts, all are black belts, right? Just for a discussion. 5,000 people we have trained so far. Now, how many we may train further? So many, isn't it? All the black belts we are going to produce. If I have all of them, or if I have all their marks in a single Excel sheet, then the data is population data. Do you understand? What is population data? The marks scored by all our black belts in the past, present, as well as future. That means we are never going to have all the data in our Excel, isn't it? Population is something we can't see easily. Hope all of you understand what is population data.
Yes.
Yes, sir.
Yes, sir.
If I have a population data and then plot a histogram, the distribution is known as population distribution. The distribution is known as population distribution. Hope all of you understand the first distribution. With the best of your ability, you collect the population data and then visualize it. That is population distribution. Suppose if I randomly select some 30 students whom we have already trained and we plot a histogram of 30 students. Now, what is this distribution?
Sample.
Sample distribution. Similar scenario exists in your workplace also. Am I correct? You produce a lot of product, right? Past also you produced, present also you are producing, future also you are going to produce. You know your population. But what do? You randomly selected some 30 samples. 30 products. Now you visualize those 30. That is the sample distribution for you. So the first distribution is population, second distribution is sample. Both are understood?
Yes, sir.
Yes, sir.
Yes, sir.
The population will have a mean, population will have a standard deviation. Agreed? Understood?
Yes, sir.
Yes, sir.
Yes.
The characteristics of the population are known as parameters. But the sample also will have a mean, sample also will have a standard deviation. If I am able to get my sample mean exactly equal to the population mean, if I am able to get the sample standard deviation exactly equal to the population standard deviation, that means I have understood my population completely just with the help of 30 samples. Am I right?
Yes.
Because I want to understand the quality of my population. Quality of my population depends on its average and its standard deviation. So in order to judge on the population parameter, I calculate statistics using sample data. Anything that you calculate using the sample data is known as statistics. What are the statistics here? Sample average, sample standard deviation. Why do we calculate sample average and sample standard deviation? Because we want to estimate the population average and population standard deviation. How do we call population characteristics? Parameters. How do we call sample characteristics? Statistics.
100.
Statistics. And what are the symbols we use for population parameters? Mu and sigma.
Mu.
Whenever I write mu and sigma, that means I am referring to population characteristics. If I use X bar and capital S, if I
Sample.
use X bar and capital S, I am referring to sample characteristics. All of you are with me so far?
Yes, sir.
But the challenge is it is difficult to get your X bar closer to mu or equal to mu. Difficult to get your capital S closer to sigma or equal to sigma. If you can get closer value, your decisions will be more realistic. Yes or no?
Yes, sir.
Yes.
So
Yes, sir.
we have a third method. third method is, instead of working with the sample distribution, we will work with sampling distribution. Here the chances of your statistics appearing or becoming, appearing closer to the population characteristics are very high. Sampling distribution means, imagine you are 36th batch of black belts, all right? Now what I do is, I'll take a sample of 5 or 10 black belts from this batch. 35th batch, I get 5 people. So to best of my ability, from all batches, I will take 5 black belts. Now each batch, how many sample I am taking?
5.
This is known as subgroup. This is known as subgroup. Now there are 35 batches. Now I have 35 subgroup. Now I can calculate 35 average, isn't it? I can also calculate a grand average. What is grand average? Average of the 35 subgroup. This grand average will be equal to your mu. Will be equal to your mu. I mean, approximately equal to. It will be very, very close to mu than your X bar. All of you understand the advantage of working with the third distribution. What is the name of the third distribution?
Sampling distribution.
Sampling distribution. Central limit theorem is talking about sampling distribution. You see here. In order to make your X double bar become very close to mu, all that you need to do is you need to ensure sufficient subgroup size. Instead of taking 3, you can take 5 or you can take 6. Maximum people go is 25, not more than that. That's point number 1. Another thing is 25 subgroup averages. Will you be able to calculate standard deviation of 25 subgroup averages? Do you understand? 25 subgroup averages means how many data points you have? 25 data points, right? I mean 25 averages you have. I want you to type each of the average in an Excel. Now how many data you will have? How many data points you will have in your Excel sheet?
25.
25. I want you to calculate a standard deviation using these 25 averages. Now this standard deviation is known as standard error of mean. This standard deviation is known as standard error of mean. So the sampling distribution has a characteristics. Its central value is grand average, which is X double bar. Do you understand? Which is X double bar. Then the another characteristics is standard error of the mean. Just now I taught you how to calculate X double bar, how to calculate standard error of the mean. All of you understand?
Yes, sir.
Yes, sir.
Yeah. So this standard error of the mean and then your X double bar can help you to judge on your population distribution, or you can predict anything, right? So there are 3 things: mu and sigma, X bar and capital S. What is the last one?
X double bar. SOE.
SEM. Very good. Standard error of mean. But calculating standard error of mean, you have to have a subgroup from several batches, isn't it? But sometimes what happens, situation may not allow you to take 25 subgroups. Then also you can have a method. I'll tell you, if you have limited number of samples, let me take my pointer. Where is it? Yeah, pointer. The standard error of mean, if I want to calculate SEM, the standard error of mean, if you can't afford taking too many subgroups, in case if the population standard deviation is revealed, known to you, Now, this is the formula for standard error of mean. Do you understand? Yeah, one method is you go for 25 subgroup, 25 subgroup average. Then you calculate a standard deviation out of it. That is, tedious because 25 subgroups spread over, a longer period. Suppose you don't have a time. Then if the, if the population standard deviation is known, this is a shortcut method. Hope all of you understand what I'm speaking. Suppose if population standard deviation is not revealed, nobody is willing to share with you. Now, in the place of sigma, you can use S. Now, what is N? Subgroup size. This is more accurate. This is more accurate. This is less accurate. Whenever sigma is not available, you can go for S. Right? Or otherwise, another method, what I told you, that you can use. Here, the secret is, mainly with the N only, subgroup size. And now the central limit theorem says your sampling distribution will always follow normality. Sampling distribution will always follow normality irrespective of the population. This rule only depends on subgroup size. What is required? Sufficient subgroup size is required. That's the reason why conditionally correct is the correct answer. Hope all of you understand what
Yes.
central limit theorem is. Right? So
If they would have
central-
mentioned, sir, if they would have mentioned 30 as a sample size, then we could have said always correct. Probably still, right?
No, see, the statement is they are trying to define the distribution. Which distribution? Sampling distribution.
Sampling distribution.
Sampling distribution may be normal, may not be normal. If I say sampling distribution may be normal or may not be normal, it is always correct. Because it can be normal or it can be non-normal. That's all. Both possibility I have brought in my statement. Now it is always correct.
Okay.
Right? But sampling distribution will be normal. Now, what is the condition it is bringing? With the sufficient subgroup size or with the sufficient sample size. So that's a theory. People realized that when I keep on collecting samples in subgroup and see how my average is moving, they realized that the average will move like a bell curve.
Got it, sir.
For
But it
that,
depends.
for that to happen, for that locus to become a bell curve, only requirement is subgroup size. No matter how your population distribution is, whether it is normal or non-normal, no problem. Even if the population is non-normal, sampling distribution will be normal. A non-normal problem can be converted into a problem with the normal distribution.
Depending on the
Depending on how
number
you
of
take the
sampling that we have picked up.
If you learn to take samples in subgroup, you can convert literally any problem in the world into a problem and which can be solved by normal distribution.
Got it, sir. Okay.
That's the idea, right? So now we move on to another part, baseline performance. An extrusion die is used to produce aluminum rods. Yeah, I hope all of you know aluminum rods, right? It's a rod. The diameter of the rod is a critical quality characteristic. Specifications on the rods are 100 plus or minus 0.5 inch. That means upper spec is 100.5, lower spec is 99.5. The process average is 100.31 and the estimated standard deviation is 0.05. And you are asked to compute the CP. All of you, do you know the formula here for CP? Can you please tell me what is the formula?
USL minus LSL.
Very good. USL minus LSL divided by
Standard
Come on.
deviation.
Static sigma.
USL minus LSL. Okay, you are right with the numerator. And what is
Divided by
denominator?
6 sigma.
Standard deviation.
6 times standard deviation. You all can use this formula and then you will be able to see this answer. Do you think all of you will be able to do this kind of simple calculation yourself manually? right? But your answer must be accurate, isn't it?
Yes, sir.
So for that purpose, in order to get accurate results, we have
Excel
shared a
sheet.
template, right?
Excel.
What is the template? I have shared, RK has shared several templates, but I shared only one. But that will do all the job. See here, sigma level calculator, V6. This is the one I have shared. See, you can learn a lot from this particular Excel file I shared here. You'll keep learning from the Excel file if you know, keep coming to us. For example, in the many things we will be learning in the next level of the program, which is MBB, right? Can you see the sigma level calculator, discrete data situation, and where is that CPCPK calculator? Yeah, CPCPK calculator. Can you see CPCPK calculator? Here I am going to type. So what is the upper spec? 100.5. What is the lower spec? 99.5. Can you tell me how much is the average? They have told you 100.31.
Yes.
So standard deviation, how much they told?
0.05.
I'm showing here again, 0.05. Very good. You
0.05.
remember correctly. So 0.05. Where is the
So
Excel
this
file?
fit.
Here. Yeah. So 0.05. If I do all this and then enter, what is the CP value that is appearing?
3.33.
Now this is accurate, right? So it takes care of all the formula in the background. Same formula only. You can do it manually, or this will do it for yourself, right? For you. So now 3.33 is the correct answer, right? So all of you understand how to use the sigma level calculator?
Yes, sir.
Yes, sir.
It is not that difficult, but then also, if you don't even do it once, then you will do the opposite while doing the exam, right? Exactly at the USL, you will type the LSL value. Exactly at the LSL, you will type the USL value. And then we all will become mad, right? So we should avoid. So do it once so that you can be comfortable handling a specific scenario. So 3.33 is the answer. Now, next scenario. Desktops are being inspected to check whether the following components are functional: RAM, motherboard, screen, hard disk, Bluetooth, and memory slot. How many checks they are making? 6 checks. 6 components are checks. 6 components are checked, inspected. That means the number of opportunity is 6. Number of opportunity for defect is 6.
6.
Now they inspect 1000 laptop. They noticed 238 defects. Now for this scenario, you need to calculate ZST. All of you understand the scenario?
Yes,
All
sir.
of you understand the scenario? Now how will you solve this scenario?
3.25, sir. Excel by using Excel.
Very good. So sigma level calculator, I think the previous one. Now situation 2. No, situation 1. Because here, there you also have an opportunity to type the OFE. You know what is OFE? Opportunity for error or defect, which is 6. Now 1000 laptops are checked. Now how many defects are noticed?
238.
Now what is the ZST? Ashok has already confirmed. It is 3.25. Suppose if they ask DPMO, will you be able to calculate for the same scenario?
39667.
238 divided by
39.
6 by 6,000.
It is straight away available, 39,667.
6. Okay.
Suppose if they change the question, this is not 238, this is 476. You also change, if they change the question, then you also change the number here. You really don't have to buy out anything. You need to know how to handle a situation. Now, hundreds of questions can be framed and you can solve all 100 questions. Instead of 1000, if it becomes 2000, then performance improves. Performance improves, you can see that your ZST is going up. Your DPMO is going down. Suppose if you notice this,
If they
yes.
don't give OFE means,
If they don't give OFE, then you come here. See here, no OFE. 3000 pieces checked there, right? and let's say 467 defects. You enter. Now you have all the results.
Yes.
All right. So this is how. So the templates are, doing the required job, and you can work with you can get the answers. Now, next question. The dimension of a particular part should be between 125 mm and 130 mm. Now, what is these numbers? 125 and 130?
Specification limit.
125 is lower spec, 130 is upper spec. An operator collected a sample of 100 parts. He found that the process average is 126 and variance is 0.25. You are supposed to compute ZLT and ZST. Will you be able to do it? Now, anybody, can you do it for me by sharing your Excel file now? This is the scenario. Who can do it? See, unless and until you put some effort from your side, you cannot master this subject. So far, you attended the training, you know all the theory better than us. Hereafter, you need to actually, spend time to master the subject. Now, who is going to handle this scenario? You want me to handle? Okay. So, please remember the values for me. Now, I come here, sigma level calculator. Here something is available. Can you see? Mean is standard deviation, USL, LSL. Can you tell me what is LSL?
LSL 125.
125.
125, yeah. Okay, LSL.
USL
USL
130.
130. Then average and standard deviation I want. How much is the average?
126.
Average is 126. Then standard deviation.
0.2.
Please note standard deviation is square root of variance, isn't it?
Yes, sir.
So that you should
Fine.
know. So equal to SQRT of square root of the variance. Variance is how much?
0.25.
0.25. So what is square root of 0.25? 0.5.
0.5.
So that 0.5 only I am typing here. Little tricky, but not difficult. We know standard deviation is square root of variance. So they have given variance. Assuming that you know the meaning of variance, right? So you convert the variance into standard deviation and apply here. Now, once I apply, the DPMO automatically comes. Long-term sigma level is 2. Short-term sigma level is 3.5. Now you check whether similar numbers are there in the option. Is it available?
Yes, sir.
So hundreds of questions can be framed in this manner. Am I right? Isn't it? Hundreds of questions can be framed. Instead of dimension, they can say length, they can say cycle time, lead time, isn't it? They can say the sales turnover, 125 crores and 130 crores. Similar scenarios, right? Ultimately, to define any specific scenario, you only need 2 numbers. What are the 2 numbers? Can you tell me? Average, standard deviation. All right. Okay. A KPO processes reimbursement received for their customers. The time to process the refund claim is 30 minutes and the customer expects the invoices to be processed between 25 minutes and 35 minutes. So LSL, USL is given. Now compute the ZST value. But see here, they have not given you the process average. They have not given you the process standard deviation. Both are required. But instead, they have given you the complete data. If complete data is given, will you be able to calculate average? Will you be able to calculate standard deviation? You calculate, understand, and then use it in your formula. What you need to calculate is ZST. So again, how to handle this? You go to the sigma level calculator. First of all, the data is required. Data will be given in the exam, right? So there should be, a small link. If you click that link, then the data will open in a spreadsheet. But if you have any problem with opening the data from the exam portal, you can use these backup data if the same file, is required. See here. I'm just searching whether refund is available here. Can you see refund here?
Yes, sir.
Yeah. So now there are so much data. This is what they are talking about. Refund, KPO, process reimbursement. Now I want the average of all this number. How to calculate average here? Equal to average. And then I just have to select everything. And then I should close. Now the average is how much? 22.099295. You have to remember, please remember. Then standard deviation. This is a sample data. So I select .s. Same manner, I select this. Now can you see the average and standard deviation?
Yes, sir.
Yes, sir.
Now I have copied this. Ultimately, I want ZST, ZLT. So where should I go here now? Probably
Sigma
sigma
level
level calculator.
calculator.
So those two values copied. I'm not able to bring it here. Okay, I hope you will help me. So the first of all, the LSL is 25, USL is 30, yeah, or 35, yeah.
30, sir.
Okay,
30, sir.
30, sir. 30.
okay. Is it so? Okay, 30, whatever. And now mean is how much? 22.009.
9. 09, sir.
Yeah,
092.
22.092. And standard deviation?
Um,
5 something.
8 point.
no, 5.9 something.
That means none of you are having a pen and a paper with you. Right?
We are having this.
Yeah, then you can. Okay, no problem.
5.96.
5.96.
So we just have to use that value. Let us go back. 5.96.
5.9.
Here, I believe. Okay. 5.96. And the question also I need to read. Anyway, something is coming here, but I think in the question, the information given is, let me check.
It's
Information is given is, okay, 25 and 35, right? So I just have to make here also 35. So whatever they ask, you just use that. You try to answer. Now, what is the ZST? 0.97. Correct?
Yes, sir.
So I just go here again. Now let me check whether 0.97 is available here. 0.97 is available, right?
Yes, sir.
All right. Now tell me, will you be able to handle this question? Laptops are being inspected to check whether the following components are functional. RAM, motherboard, screen, hard disk, Bluetooth, memory slot. Again, opportunities is how many? 6. 500 laptops inspected, 119 defects observed. Now you please calculate. All of you have the sigma level calculator with you, right? And now I'm not going to do it. All of you can do it parallelly. And please tell me which is the answer. 30 seconds for you. Tell me. Simple one, right? You open the sigma level calculator.
3.25.
3.25, yeah. All of you agree? Sridhar Rajan is correct?
Yes, sir.
Perfect.
3.25, sir.
Very simple. Now you all know, right? Whatever be the scenario, you just know where to get the answer. Now, moving on to the next. In a MSA study based on variance, gauge R&R equal to 0.59 and total variation is 0.62. Find the part-to-part variation. I hope all of you know that always the total variation is equal to measurement variation plus part-to-part variation. All of you agree with this equation? Total variation is equal to measurement variation plus part-to-part variation. What is part-to-part variation? Process variation. All of you understand the equation? I repeat the equation. Total variation is equal to measurement variation plus part-to-part variation. Now see, measurement variation is given gauge R&R. Total variation is given 0.62. Now what you need to calculate is part-to-part variation. So can you frame a formula for part-to-part variation? Part-to-part variation is equal to Total variation
Total minus gauge around.
minus
Variation.
measurement variation.
Minus gauge around.
Very simple. So 0.6 minus 0.5. Whatever is the difference, are you able to see here? 0.6, 0.0.
0.0032.
Oh, the last one is the
D,
correct answer,
D.
right? Hope all of you are getting this. 0.0032. Are you getting all of you?
Yes, sir.
0.032.
0.032, sir. C,
That
C.
means C is the correct answer, not D. Simple. You subtract 0.59 from this, so you get. So 0.032 is the correct answer, whatever comes. A black belt is developing a FMEA study in a software development unit, and the following ratings are given: severity 3, occurrence 2, deduction 9. Now, what is the RPN number? Will you be able to calculate RPN here?
39.
3 into 2 into 9.
54, sir.
4.
Very, very
54.
simple, right? 3 into 2 into 9, which is 54. Simple. Now, this is a little tricky question. Find the sample size for a one sample G test. The hypothesized difference in the mean is 0.5. The population standard deviation. What is the symbol for population standard deviation? Sigma or capital S or SAM?
Capital S.
Sigma.
Sigma.
Mu is mean and sigma is
Mu
standard.
or sigma?
Sigma only. This is standard deviation. Sigma only.
Okay.
Sigma 0.75. Power of the test is 0.95. Confidence level is 0.95. To fulfill this condition, how many samples are required? Do you understand your situation now? You have to prove that the mean has increased by 0.5 unit or the mean has decreased by 0.5 unit. I don't know. It is difference. It can be any characteristics, you know. The average is shifted by how many units? 0.5. Now, how many samples you need to have in your experiment to convince everyone around you? To convince everyone around you with a confidence level of 95%, power of the test of 95%. All right. So remember this number. I'll show you. For this, I want you to use Minitab, right? So you have to help me with the numbers. So I'm showing my Minitab screen now. Now what you need to do is you need to go to stat. Can you see power and sample size?
Yes, sir.
Now power and sample size, choose one sample G test. Now sample size, straight away it is asking sample size. That is our question also. We don't know. Leave it. Now difference. How much is the difference in the mean? 0.5.
5.
What is the power you want?
0.95.
0.95.
What is the known standard deviation of the population?
0.75.
0.7.
0.75. Give options. Now, we don't know whether the difference is above or below. So let it be not equal because they have not given. So it's a two-tailed test. Average has either increased or decreased. So it's a two-tailed. Now significance level is 0.05. That means confidence level is 95. I want 95% confidence level. So I am typing 0.05 here. Now tell me what are the values I typed? Power of the test, confidence level,
Sigma level.
difference in the average, difference in the mean, isn't it? That is 0.5. And population standard deviation. All of these things decides your sample size. Do you understand how many factors we now typed? Not only
4.
difference in the average,
Power of
population standard deviation, power, confidence level or significance level, and so the fifth one is sample size. All the 5 are interrelated. If you can decide on the 4, fifth one will be decided by the 4. So that's what we are going to understand now. I'm giving okay, one more okay. Now you can see the power curve. What is this power curve is telling me? To
30
achieve
samples.
to achieve a power, the required power of 95%. You see here, power is here. And to validate a mean average, to validate a difference of 0.5, minimum how many sample you should take?
30.
As the average increases, probably sample size will decrease. As the difference in the average increases, sample size might decrease, isn't it? Shall we do that? Shall we try that? Stat, power and sample size, same situation. Let me say instead of 0.5, 0.75. What do you think will happen to your sample size now? Maybe not 0.75, let me make something. Difference is 1.5. Now I increased the difference in the average. What do you think will happen to the sample size?
Decrease.
Decrease. Very good. Can you see? To prove a difference in the average of 4 units, I don't require 30 samples. 4 samples will do for me. But as the gap, as the difference you want to prove becomes narrower, then the challenges are more experiments are required. So for this question, the answer is, what is the answer we have seen?
30, sir.
Do you have 30 here? 30 is the
sir.
answer. If they change the numbers, you change and then get it. Now a hospital wants to determine whether there is any difference in the average turnaround time of the reports generated by the laboratories on the particular test. They collected a random sample and recorded turnaround time for 4 reports of 4 laboratories. Stat is defined as the sample collected to report dispatch. Assuming the data is normally distributed, equal variance, analyze the data and determine a significant difference in average turnaround time among the different laboratories at 5% significance level. That means there is a hospital where there are 4 diagnostic laboratories. As a chief of the hospital, what do you think is all the 4 laboratories have the same facility, same staff members, same level of training and everything. Obviously, the turnaround time should be same, isn't it? For a particular test. Yes or no? You have 4 laboratory. You have 4 laboratory and a particular diagnosis is performed in all the 4 labs having similar equipment. So the time required is expected to be more or less same. Yes or no? All of you, do you understand or not?
Yes, sir.
Very
Yes,
simple
sir.
scenario. Very simple scenario, right? 4 similar laboratories, so similar time for the similar diagnostic. But suddenly you have a doubt. Maybe is there any particular lab working slow or any particular lab doing the work faster? You don't know. You want to understand as a chief of the hospital. So what you do is you actually look at the data and try to understand whether any particular lab is performing significantly different. Do you understand? This is the situation. Now, what is the test you should do? You should do.
ANOVA.
Very good. You should do ANOVA, right? So for that, we need data. So I'm sharing the Excel file to capture the data. So the file they mentioned is turnaround time. So I need to look for the turnaround time. It's here. So I just have to copy all the data. I've copied. And now I will take you to Minitab. RK has taught you how to do all of this in Excel itself, right? ANOVA and all. But I am helping you with Minitab only. Now all the data copied and then pasted here. Now if I can perform ANOVA and see a p-value of lesser than 0.05, it simply means there is significant difference between the laboratory, right? So let me do it. Stat, ANOVA, one-way ANOVA. Now, all the data are in separate column. Response data are in a separate column. Yeah. Now I selected that. I came here. Now I have to select all the 4 labs. Now always for ANOVA, you must assume equal variance. Always for performing ANOVA, you must assume equal variance, which is a prerequisite. Either you have to assume or you have to test. You assume. Now you give OK and one more OK. Now ANOVA is performed. First thing to look at is p-value. Alternate way of understanding the significance is the visual graph. Now, what do you understand looking at the visual graph? What are these red blue color dot? The average turnaround time for laboratory 1. Average turnaround time for laboratory 2. Do you notice any significant difference between 1 and 2?
No.
No.
This is two sample t-test you performed and you immediately understood that there is no significant difference. But look at laboratory 3.
Huge difference.
Significant
Do
difference.
you see a
It's
problem here?
significant.
Do you see a problem here?
Yes,
Yes.
What is the
Yes,
problem
sir.
you see?
they're taking more turnaround time.
More
They are
time.
taking more time. Now you can say laboratory something wrong with laboratory 3 because the difference is significant. Why do you say significant? Because the average turnaround time is seen completely outside the confidence limits. Can you see an I channel here?
Yes, sir.
In the I channel, the center is the average. And what is this horizontal line on the top?
Upper
That upper
specification limit.
specification limit, lower specification limit.
Lower specification.
Not specification limits. You can't use the same language, in all situations. Specification
Significant
limits
level.
are decided by customer. Now this is mean. These are upper confidence limit for mean and this is lower confidence limit for mean.
For me.
There are you can see here 95% confidence limits. Upper limit, lower limit. But when I compare between 1 and 2, the confidence interval, the height of the line is the confidence interval. The complete height of the line or major portion of the height of the line is overlapping the height of the another confidence interval for laboratory 1. Am I right? If there is a overlapping, there is no significance. P-value is more than 0.05. But here, look at this vertical line. What is this vertical line called? Confidence interval. The complete confidence interval is outside the confidence interval of laboratory 1, laboratory 2, as well as laboratory 4. Can you see that, all of you?
Yes.
Yes, sir.
That is why laboratory 3 is considered to consumed significantly higher time. Now your decision is perfectly all right. You are at least 95% confident that laboratory 3 some action is required. Similarly, do you see a significance with laboratory 4?
Yes.
They are significantly better
Less.
than anyone else. So you can make a conclusion only when you see the confidence intervals, in no overlapping condition. If confidence intervals are overlapping, that is nothing but the scenario where p-value is more than 0.05. Now, in this scenario, we have understood significance. That means p-value should be lesser than 0.05. Can you see p-value here?
Yes.
Either you understand visually, or you look at the p-value, or you look at the f-value, the meaning is same. P-value lesser than 0.05, f-value 118.70, or the confidence interval completely appearing the other confidence intervals of other factors. All are same. That means there is significance, right? If there is significance, you are allowed to take decision by referring to the data. Now you refer the data. What do you understand? Which laboratory takes more time?
3.
Laboratory 3.
3.
Now action can be taken. Action can be taken for laboratory 3. Now which laboratory takes less time?
Laboratory 4.
4.
Now laboratory 4 can be rewarded and laboratory 3 can be given a penalty. You are absolutely correct with your decision. All right. So now we move on to the thing. For a particular test, alpha equal to 0.05, beta equal to 0.1. What is the power of the test? Come on. Alpha equal to 0.05 means what is the confidence level? 95%, right? What is alpha? Level of significance. Isn't it type 1 error? Alpha risk. The type 2 error, beta risk. Beta risk decides power of the test. Alpha risk decides confidence level. Now, how much is your beta risk?
0.1.
0.1, 10%. So, power of the test is 90%. So, what is the answer? B.
How
All
come,
right.
sir? Sir,
If
I will-
alpha risk is 5%, then confidence level is 95%. But in this case, they are talking about power of the test. So you must understand the beta risk. Beta risk is 10%. So power of the test is 90%. If I change beta risk to 20%, then what will be the power? What will be the
80%.
power? 80%.
80%.
80%.
That's all. Now find the significance level when the characteristics value is not allowed in the extreme and beyond 1.5 standard deviation on either side. See, they have not explained any scenario, but they are asking you to find out something. This is called statistical scenario, ideal scenario. Only whenever the scenario is ideal, you must use standard normal distribution. We don't know which industry it is. We know which product it is. They are only talking in terms of standard deviation. Can you see here? They are saying that your characteristics is shifted beyond 1.5 standard deviation. Can you understand that much by reading the line?
Yes.
I need some yes.
Yes, sir.
Do you understand? Yeah. They are saying that characteristics is shifted beyond 1.5 standard deviation. But what is the characteristics? We don't know. What is the average? Not mentioned. This is the exact scenario where you can use standard normal distribution. Let's see how we can handle this. I'm showing you Minitab again. Now go to graph, probability distribution plot, view probability. Now it is not a real-time scenario like the students mark, isn't it?
Yes.
Characteristics, no information about the characteristics. Only know some statistics is available. So mean equal to 0. Standard deviation equal to
1.
This is called standard normal distribution. When to use it? If the characteristics and central values are not informed. But they give a clue that your characteristics shifted beyond how much standard deviation? 1.5 standard deviation. So go to shaded area. So now I want to find out what is the probability for my characteristics to go beyond 1.5 standard deviation. So can I take the third graph, both tail? Right? Can you see the gray? Beyond a line on the right side, beyond a similar line on the left side. 1.5 on the right side, 1.5 on the left side. I choose this. Now, what is the deviation? 1.5.
Five.
My characteristics from the center is moved to the right by 1.5. Similarly, move to the left by 1.5. Now, what is the chance for my statistics to cross this 1.5 line? Let me ask Minitab. I should give X value, sorry. So, I should give X value. Okay.
I remove the 1.5 then.
Remove 1.5. Give X value. Now come here. Now I type 1.5. Now I am giving, this I should choose now.
Both.
Now let me give OK. Now, how much is the chance? Can you see here? 0.066. That means 6.6% chance is there for my characteristics to go beyond 1.5 standard deviation on the right side. Similarly, 6.6% on the left side. So what is the total percentage, total chance?
12%.
13.2.
13.
If your characteristics is inside 1.5 standard deviation, your company says it is okay. But your company is not okay. No, they are not, I mean, they don't want to consider, they want to consider any observation outside 1.5 standard deviation as significant. That means this is the line of significance. So the level of significance is 13.2. So alpha is 13.2. So let me go to the slide now. Now tell me, now what is the significance level? What is the significance level?
13.36.
Your company don't want to see their characteristics, to see their product characteristics appearing in the red color area. What is the percentage of the red color area? 13.36.
13.6.
What is the definition for red color area? Or what is the point, what is the value of the line of significance? 1.5 standard deviation. Right? So 13.36. When I say level of significance is 13.36, that means the balance 87 is we call it, confidence level. Okay. Now we have only 3 more slides. Let us complete and then we can wind up. If the correlation coefficient is 0.9, the percentage of variation in the response variable explained by the variation in the explanatory variable. Can anybody able to answer this question? Correlation coefficient is 0.9. What percentage of the variation in the Y can be explained by the explanatory variable? This we have discussed in the correlation analysis. Can you multiply 0.9 or can you square the 0.9?
Square.
R square. 0.9 multiplied by 0.9 is how much?
81. 81.
81%.
So 81% of the influence is coming from the explanatory variable. When I say explanatory variable, is it X or Y?
Why?
Explanatory variable is X. Response variable is Y. All right. Okay. The coefficient of correlation between U and V. U equal to X and V equal to minus X. That means U equal to minus V. Now, what is the correlation coefficient between U and V? -1.
-1.
Because they are opposite to each other. You can see here. They are equal, but they are opposite. That means it is -1. In two-way ANOVA, with one factor at 4 level, another factor at 3 level, without replication, what is the total degree of freedom? First of all, tell me what is the total number of experiments with one factor at 4 level, another factor at 3 level?
12.
So what is the degree of freedom?
-1.
11.
11.
11.
You know the answer. 11 is the correct answer. In one-way ANOVA, with 4 levels of a factor, without replication, what is the degree of freedom?
3.
4 -1.
If replication is given, then you need to account it properly, right? Okay. A process excellence team in a bank is inspecting transaction. There are 7 opportunities for error in each transaction. 100 transactions are inspected every day. A number of errors are recorded. Which control chart will you use to study and keep the process in statistical control? Do you know how to choose the control chart?
Teacher.
Broadly, there are 2 categories. One is variable chart. Another one is attribute chart. You all know what is a variable continuous data. When to go for attribute chart? Data is discrete. Now tell me, is this data continuous or discrete? Discrete.
Continuous.
No. Continuous means measurable. Here it is countable. See here.
Right.
Out of 100 transaction, they are saying, no, they are checking and then they found that out of 100 transactions are inspected and number of errors are recorded. Number of errors is nothing but number of defects. So whenever you are working with the defects, because again within attribute, there are 2 categories. One is defect, another one is defective. If it is defect, you should go for C chart or U chart. I'll tell you when to go for C and U. But both of them, one of them should be used for defect chart. Another control chart or another set of control chart are known as defective chart. I hope all of you learned in the very first day itself, difference between defect and defective. Am I right? You all know, right? Difference between defect and defective.
Yes, sir.
Now, what are they talking? Are they talking in terms of defect or are they talking in terms of defective?
Defects.
They are talking in terms of defects. Because in every transaction, there are 7 types of defects possible. And out of 100 transactions, they are studying the error with respect to all the 7 opportunities. That means they are not just trying to find out the whether the transaction is success or failure. When they are checking whether the transaction is success or failure, they are talking in terms of defective. But how do they talk? They are talking in terms of the number of errors in each transaction. That means they are talking in terms of defects. Now, the option is only between C and U. Do you understand, all of you?
Yeah.
Very good.
Yes,
Now, in order to choose between C and U, you need to ask yourself whether the sample size is constant or changing every day or changing every time. See here, they are telling you clearly 100 transactions are inspected every day. That means sample size is
Constant.
Please, in that situation, go for C chart. If it is not constant, you can go for U chart. All of you understand when to go for C and U chart? And Minitab will do it for you. You should only know which chart is appropriate. Now, another situation. An inspection process checked parts produced for defectives. Now what are they monitoring? Defects or defectives?
Defectives.
Defectives. So C and U are not applicable. So choice is P and NP. How to figure out P and NP? Depending on sample size. The total number of parts produced shift-wise and the number of defectives were recorded. Every shift, how many parts produced is recorded and defectives also recorded. Now, do you think the number of parts produced shift-wise will be a constant or will be a variable? Come on. Number of parts produced every shift. Constant or variable?
Variable.
If it is variable, you should go for P chart. If it is constant, you should go for NP chart. Now you know the logic of selecting control charts. Earlier I have taught you X bar R chart, X bar S chart, and IMR chart. What is the logic for selecting X bar R chart? Data must be continuous. Subgroup size must be less than 8. You remember? Subgroup size more than 8, X bar S chart. Subgroup size equal to 1, IMR chart. But 3 charts for continuous data, 4 charts for discrete or attribute data. And within the 4, the classification we now discussed. Now, which of the following is not included in the list of 7 waste?
Proactive.
No proactive.
No
risk
proactive risk
No
analysis.
You are correct. You are correct. Which of the following technique dramatically shortens
Single minute
changeover
exchange
time?
of dice.
SMED.
SME.
Very
SMED.
good. Very good. A system that delivers products or services at the correct time and in the correct quantity is referred to as.
Just in
Just in
time.
time.
Just in time.
Just in time.
That is what we are also doing, right? You have the exam tomorrow or day after tomorrow, right? Day after tomorrow. And we are discussing the exam questions at the right time. Such a system is known as just in time.
Just in time.
So doing just in time is always good, isn't it? There is no delay, there is no wastage, and there is a compelling reason to perform right at the first time. Such a system is known as just in time. Now all good. Now I hope all of you are fully ready to crack any examination. Right? You can definitely score above 90%. All the best.
Thank you, sir.
Thank you.